Hi, this is just an explanation of how to convert a decimal number into a binary number. So our first question is that in base 10, that's in decimal, and how to convert it into a binary value. So, now the basis for our number conversions, in binary we need to understand that the far right hand column of any binary number has the smallest value. And as we move a position to the left, that value increases. So if I just insert a table here, we will go 10, should we go 12, 12 and 2. Okay, so here we have place, and here we have value. Okay, so let's assume we have this number, okay, so far right hand column in binary, we know it's worth 1. We know that every move to the right, its value doubles. So that's worth 2, that's 4, that's 8, that's 16, that's 32, that's 64, that's 128, that's 256, that's 512, and this is 1024, which is where we'll stop. Okay, so you can see that each one of these columns is worth a different value. Okay, so in order to convert a decimal number into a binary, we need to have, we need to add up any column value if there's a 1 underneath it. So the best way to do this, the conversion, we go 249, the biggest number that will fit into 249 without going overshooting it is 128. Because if we have one lot of 256, obviously we've already overshot our value of 249. So I'm going to put a 1 there. Then what we need to do is we need to work out how many we have remaining. So I do it as this type of calculation. So I know when I minus 128 from our initial value, 249, I get 121. Okay, again, I do that same process again. I go 121, the next number down, 64. Yep, it's not greater than 121, so I'm going to have one lot of that in there. I'm going to do that same calculation again, so this time with different numbers. So I started with 121. I've now minus 64 from it. What do I have remaining? So I have 7 units, so it'll take me to 71, and so 57. 11, yep, that's correct. So again, I do that same process again. 57, the number that's less than or equal to it is 32. So same calculation again, 57 minus 32. In this case, I have 25. Same process again. Number that's less than or equal to 25, 16 minus 16. And that leaves me with 9, 8. 8 fits in, that's perfect. So 9 minus 8, I've got 1. Okay, so this is where I go 4. If I add 4 to that equation, am I going to overshoot by 1? Yes. 2, nope, and 1. Now, so then I've done 1 minus 1, hopefully equals 0. So if I go back now and I add up all of these values, if I add up 128, and then I add 64, and then I add 32, and then I add 16, 8, and 1, if I've done this correctly, I should end up with 249 as a decimal value. So let's just see if that's the case. 128, so we'll go like this. We'll go 128 plus 64 plus 32 plus 16 plus 8 plus 1, 249, and 249 is what we're going to get back. So our decimal value binary value of the 249 as decimal is 1111101. Obviously, to indicate binary, you can put a little number 2 as a subset. We're going to make it subscript. Perfect. And that just means we're talking in binary. Okay. So that's the answer of how to convert 249 as a decimal into a value of binary.